Looking at quadratic equations. So a lot of this should remind you of maybe second semester algebra, maybe a lot of stuff from Algebra 2. But today should be hopefully a little bit of review revolving quadratics and the four main ways that we wind up solving quadratics. Number 5, learning target for the unit, solve quadratics by factoring. Number 6, solve quadratics by taking the square root. This one would be probably the easiest version. Solve quadratics by completing the square. And this really just kind of backs up what you do here. And then number 8, everyone's favorite, solve quadratics by using the formula, meaning the quadratic formula. All right, so just a few basics before we get to our examples. So the zero product property says this: if A times B equals 0, then A equals 0 or B equals 0. One of the two of them has to equal 0 if, when we multiply them together, it equals 0. This typically comes into play after we have factored a quadratic trinomial. So if you have something like x plus 2 times x minus 5, here we have two things multiplied by each other, like an a and a b. And if this is equal to 0, I know that either this has to equal 0 or this has to equal 0 in order to make the whole equation true. And so I think to myself, all right, what value for x makes this equal to 0? And of course, negative 2 does. And if I plug in negative 2 plus 2 is 0, and 0 times whatever this is makes it equal to 0. But of course, we have another solution here if x equals 5. Well, 5 minus 5 is 0, and 0 times whatever this winds up being is 0, and it makes it a true equation. The one big thing here, if you're going to solve an equation by completing the square step, making a trinomial, a perfect square trinomial. So if we had something like ax squared plus bx, and we wanted to make this a perfect square, we would want to pick the c value that would make this a perfect square trinomial. And what that would always wind up being would be you take b, whatever this value is, you would divide that by 2, and then you would square the whole thing. So take half of b squared, whatever that is going to give you a perfect square. And that'll allow you to turn it into a plus b, or half of b squared. And when we have that, well, then it'll be a lot easier to solve by taking the square root. All right, and then kind of the last big thing is the formula. So x equals, so I guess first of all, we'll say if you have something in standard form, ax squared plus bx plus c equals 0. Remember, it's got to equal 0, that's a key. If this is the case, then the quadratic formula, which will just take us right to the answer, we can use this on any quadratic that we want, is negative b plus or minus the square root of b squared minus 4 times a times c. Take it all and divide by 2 times a. All right, now one of the not tricky things, but one of the handy things about the quadratic formula is the discriminant. So the discriminant is this whole b squared minus 4ac. And because we're taking the square root of that, that can tell us kind of what our solutions are, how many solutions we have, if we have any real solutions. So we'll call this just d, the discriminant. I guess the radical isn't part of that, but if the discriminant is greater than 0, so if the discriminant is greater than 0, then we're going to have two solutions, which means, when we graphed it out, it would kind of cross that x-axis in two spots. We have two solutions. If our discriminant is equal to 0, that means we're going to have one solution. And if we graphed it, it means it would kind of touch that x-axis in exactly one spot. And then if our discriminant is less than 0, meaning that it's negative, we're going to have no real solutions. Meaning our solutions are imaginary, and we'll have to use a lot of that complex number stuff that we did in lesson 3. Now also, if our discriminant is a square number, that tells us that we could have solved it by factoring. We might not have wanted to solve it by factoring. That could have been more difficult. But if it was a square number like 16, 25, then we could have factored it. All right. Moving on, so we've just got a wide variety of quadratics here. This first one we will solve by factoring. Now again, if I've got the zero product property, well, then I got to make it equal to 0. So first thing I'm going to do is I'm going to go ahead and make this equal to 0 by subtracting 3 from both sides. And I guess I'll use a little mathemagic here and turn this into 7x minus 18. Now this is not technically the same, so put a little asterisk next to it, but it is a helpful way of factoring rather than guessing and checking. Because now I can factor this guy. We'll say x, because that's negative, we want one positive, one negative, factors of 18, that would give me 7. Well, that would be 9 and 2. Now, if I multiplied in by 6, I've got to divide out by 6. And so, if I've got fractions that I can reduce, I'm going to go ahead and do that. I can turn this into 3 over 2, dividing both of those by 3. And then here I can divide both of these by 2 and get 1/3. Now, if I cannot divide and get a whole number, I'm going to take this denominator and I'm going to slide it in front of the x. So I wind up with 2x plus 3 times 3x minus 1. And of course, this is all still equal to 0. One of the beauties of Mathemagic is, I guess if I hadn't done that, if I'd done guess and check, I'd now have to kind of do some calculations to find what values for x would make this equal to 0 and what values for x would make this equal to 0. But because I did Mathemagic, I can just kind of look up here, and it's going to be the opposite of this and the opposite of this. So my solutions are x equals negative 3/2 and also positive 1/3. And these are the values that are going to, when I plug them back in, make this a true statement. It'll make this part equal to 3. All right, so there's solving by using the zero product property. Here's an example, a quick one, of solving by taking the square root. So if I have something squared and I want to get rid of it, the best way to doing that is just by taking the square root, and that square root will cancel out the squared, and I'll just be left with x minus 4. On the right hand side though, I'll also have to take the square root of that, and the square root of 12 is going to be the square root of 4 times the square root of 3, which would reduce down to 2 radical 3, positive and negative. Again, my mission here is to solve for x, and so I'm going to add 4 to both sides, which means I'd wind up with 4 plus 2 radical 3, and I would also have 4 minus 2 radical 3. These are my two solutions that would make this equal to each other. All right, moving right along. Next thing we're going to work on is solving by completing the square, which is one that admittedly we don't use very often, primarily because we have the quadratic formula, but it's a good thing to remember So we got kind of the simple version and the complex version. So the first thing I'm going to want to do is, it's not a perfect square right now, and I want to turn it into a perfect square. So this negative 14 is really kind of killing that. So I'm going to just move it on over to the other side. And I'm going to say, all right, x squared minus 4x plus blank is equal to positive 14. Now I need to think to myself, all right, what value of c would make this a perfect square trinomial? Well, off to the side, if I needed to, I could just take half of b and square it. Notice this will always wind up being a positive number because I'm squaring it. So half of negative 4 is negative 2, and negative 2 squared is positive 4. So if I plug in positive 4 here, I'm going to wind up with a perfect square trinomial, but because this is an equation, I want to keep it balanced. If I add 4 to the left, I'm going to have to add 4 to the right. Now on the left, I have this perfect square trinomial, and we have worked a number of times this year, and you've seen this throughout your math career. We can factor this one very easily. It's going to be x minus 2 squared. So usually you can just take half of this, and that works. And then over on the right-hand side, we've got 18. All right, now I've more or less turned this into the same one that I had before in the previous slide. I'm going to take the square root of both sides, and now I've got x minus 2. On the right-hand side, I'm going to wind up with the square root of 9 times the square root of 2, which would be positive negative 3 radical 2. And then to finish this off, I'm just going to add 2 to both sides, and so I've got 2 plus 3 radical 2 and 2 minus 3 radical 2. All right, so there's the simple version of completing the square. Now let's do kind of the grown-up version. One of the whole keys to being able to complete the square is you need to have 1 as the a value. This a value continues to give us problems. And so, well, it's going to be a little bit awkward. We're just going to have to deal with that. But we're going to divide this whole thing through by 9 so that we get 1 for my a value. So when I go ahead and divide everything through by 9, it works out okay, of course, for the a value. For the b value, sometimes that is a little bit awkward. And now we got this kind of awkward 4/3 x fraction. Here we're luckily going to get a nice number, 1. And then, of course, 0 divided by 9, still 0. Okay, so now that I've done that, I've essentially turned it into one of these, but there's still more to come. Let's see, we've got x squared minus 4/3 x. We're going to subtract the 1 from both sides to get that out of there. And again, now I want to come up with this c value. So I'm going to take half of b and square it. So half of negative 4/3 and have all of this squared. Well, half of 4/3 is going to wind up being 4/6, or sorry, 2/3, and then 2/3 squared is going to be 4/9. So my value here is going to wind up being 4/9. And so, of course, if I add 4/9 to the left, I'm going to have to wind up adding 4/9 to the right. Okay, let's see. Well, now the whole thing here is, even though this looks pretty ugly, I'm still just kind of follow the same pattern. This value here, it's going to be x, and then plus, or I guess minus in this case, half of this guy. So like half of 4 was 2. And so over here, even though it's a little bit awkward, I'm just going to say, all right, well, half of 4/3 would be 2/3. So minus 2/3 squared. And then on the right-hand side, we've got negative 1 plus 4/9. If I find some common denominators there, make that minus 9/9, I would wind up with negative 5/9. All right, well, yep, you can see that this is going to get more awkward. I'm going to take this, I'm going to take the square root of both sides. Now I'm taking the square root of a negative number. But at least on the left, things are getting simpler. I'm getting closer to my x. Right now I just have x minus 2/3. On the right-hand side, I've got the square root of negative 5/9. What to do with that? Well, I'm going to take the square root of the top, which would give me the square root of negative 1 times the square root of 5. And then on the bottom, I'd have to take the square root of 9. Well, the square root of negative 1 we know is I, so I've got, we'll just call it square root of 5I. And on the bottom, we get 3. And of course, we've got the positive and negative version of this. So positive, negative, radical 5I over 3. All right, well, I hit my final step here, and I'm just going to add the 2/3 to both sides. Now I've got x equals 2/3 plus or minus radical 5I over 3. All right, that was a good one. All right, let's move on to our final thing, and that's using the quadratic formula. So remember the big if part, and that's if ax squared plus bx plus c equals 0. And so I need, in order to use the quadratic formula, everything to equal 0. So I guess my first step here is I'm going to add 2 to both sides. And that leaves me with x squared minus 4x plus 2 equals 0. All right, so if I were to kind of lay it all out, my a value would be 1. My b value would be negative 4. My c value is going to be 2. And I'm just going to plug those all right into my formula. So I'll write it all out here. I got x equals negative b, so negative 4 would be positive 4, plus or minus the square root of negative 4 squared, minus 4 times a, which is 1, times c, which is 2, and we take the whole thing and we divide it by a. Okay, first step here is to figure out the discriminant. And so we would wind up with 16 minus 4 times 1 times 2, which would wind up just being 8. So I've got 4 plus or minus the square root of 8 divided by 2. The square root of 8 would wind up being square root of 4 times the square root of 2. So that's going to be 4 plus or minus 2 radical 2 divided by 2. And luckily for us, each one of these things is divisible by 2. And so that leaves me with 2 plus radical 2 and 2 minus radical 2. All right. Well, there's a good solid version of the quadratic formula. Let's take a look at maybe the slightly more complex version. Again, I want to make this all equal to 0. So I think I'm going to subtract x and add 4. So we're going to say 2x squared minus x plus 4 is equal to 0. So a is going to equal 2, b is going to equal negative 1, c is going to equal 4. All right, so as I go ahead and start plugging away here, I've got negative 1, should be positive 1, plus or minus the square root of negative 1 squared minus 4 times a, which is 2, times c, which is 4, all divided by 2 times a, which is 2. All right, well, as I go about doing the discriminant first, I am immediately a little bit concerned. 1 squared, well, negative 1 squared is 1, and then this whole thing would be 32, so 1 minus 32 is negative 31. I wind up with 1 plus or minus the square root of negative 31 divided by 4. Well, that whole negative thing means that there are no real solutions. I mean, I could still graph this thing, but it would never cross the x-axis when this was equal to 0, or these two things, when graphed, would never connect. So there are no real solutions, but we do have some imaginary solutions. We do know that we can take the square root of negative 31 and turn that into the square root of negative 1 times the square root of 31 divided by 4, and, well, the square root of 1 is I. So I wind up with 1 plus or minus, well, square root of 31, there are no friendly factors to that, so we'll just say the square root of 31I divided by 4. All right, and that takes us to our final answer. All right, well, I hope you've enjoyed quadratics. We're done.